Login accepted.
All right, guys. So thank you for joining this week's Swift meeting. My name is Alexander Hafty, and I'm going to present to you guys about web application firewalls. So a little introduction about who I am. My name is Alexander Hafty, and I'm a swintern for Swift this year, and I competed in Cyberforce, and I'm currently in the NCAE team for 2026. So a little So for some promotionals, make sure you RSVP for Tech Symposium. It's on March 14th. It's coming in 2 weeks. There will be free food. There's going to be a giveaway. I believe this is for Raspberry Pi. So if you want a free Raspberry Pi, make sure you join. There's going to be scavenger hunts, and you can network with all kinds of people. So make sure you join. Make sure you also RSVP for CIS Banquet. It's coming on April 19th on a Sunday. You're going, in the CIS Banquet, you're going to be able to network with other CIS students. There's going to be free food. You're going to hear guest speakers talking about cybersecurity, AI, and other topics relating to CIS. And you can win club associated awards. And everything is completely free, but space is limited to 80 people. So make sure you RSVP soon. And lastly, make sure you sign up for Swift Grad Stol if you are graduating in fall 2025 or spring or this spring. You'd be able to get a stol for $20 for the package. So here's the table of contents for what you guys are going to learn today. You're going to learn about a brief over what web servers are. Then you're going to learn how web application firewalls protect web servers from web-based attacks. Then you're going to learn how to deploy, different ways to deploy these WAFs on your network, and different ways to integrate it with other security systems. So first of all, to understand why WAFs are used, you have to understand what they're used to protect. So WAFs are used to protect web servers, but what are web servers? Web servers are the devices used to host websites and web applications. So if you've ever logged into LinkedIn or Wikipedia or YouTube, all the things you see on your screen is displayed through web servers. So they store the necessary files that allow them to show you content. They handle user requests, such as if you want to log in or you want to send a certain message. They handle those requests through HTTP and HTTPS requests. So where are web servers usually found? Nowadays, the majority of the time, web servers are located in large data centers. An example is Meta's Altoona data center in Iowa. It's, I believe, the largest data center in the United States. So whenever you're logging into a website or going into a website, chances are it's being hosted from a web server in one of these giant data centers. But in the rare circumstance that you have a physical web server in your network, it's going to be held in a DMZ zone, also known as a demilitarized zone. And this is because any devices that actively interact with users over the internet, they're going to be found in this DMZ. So just in case a security incident happens with one of these devices, it's not going to affect your local area network as easily. So how do web servers work? Web servers, as I stated, handle the complexity of displaying pages and content to users, and they operate through HTTP and HTTPS protocols. So this happens in the application layer of the OSI model. So basically, this happens all web-based. And these are handled through requests from the user and sending packets back to the user from the web server. So to better understand how these requests, these are protected, how web servers need to be protected, it's good to understand how a web server receives information from a user. So let's say you want to log into mywebsite.com. Your computer would send an HTTP or HTTPS request to this web server, but first it's going to reach the firewall. As you can see in this image here, when it comes from the internet, it's going to reach the network firewall. And this firewall is meant to see, okay, is it coming from a valid IP? Is it going to a valid port? And it's going to check certain allow rules or allow or deny rules made from that firewall to see if you're allowed to come in. And if you are, then they'll pass you right through to the web server. And keep this in mind, what this looks like. So then when it goes to the web server is going to look at this header. It's, as you can see, it's called post/login. It's going to see that, and it's going to bring it to a specific handler. This handler is designed to fully handle login credentials and certain things of logging in and user interface and stuff like that. And so when it goes to this handler, it's going to check the content of this HTTPS request. Here, it would be username is equal to guest, and your password is bruh. And it'll turn these values into SQL, into a database query. It'll query a database with all the users that belong to the website. And this SQL, it will make a SQL query as seen below. First, it will check if this username exists within the database. And if it does, it's going to check if you have the right password. And if you do, you are logged in. But there's a problem with this type of deployment on your network. First of all, traditional network firewalls don't analyze content, HTTPS content, since it mostly handles, I believe, in a network or transport layer of the OSI model. So that means that any web-based attacks are going to be let in. So let's say, for example, I'm going to show you what a SQL injection looks like without a firewall, a web application firewall. So let's say instead of having a normal username like guest or, admin, I guess, your username is going to look something like this, where this is a very basic SQL injection query, and the password can be anything. So what's going to happen is the process is going to be somewhat, for the most part, the same. It's going to go through the network firewall. The network firewall is going to see that's coming from a valid IP to a valid port, and it's going to let it in. Then it's going to be going to the web server, where the web server is going to check the /login, and it's going to go send it to the login handler, where that handler is going to send it to, going to make a SQL query with the username. Now, if you look at this part of the SQL query, it's going to say if the username is admin or 1 equals 1. That basically means since 1 always equals 1, that's a true condition. It's not going to look at this username is equal to admin, regardless if this is true or false. It's going to see that 1 is equal to 1, or it's going to see that always true condition, and it's going to let you log in as either admin or a user with lower privileges for you to escalate privileges afterwards. So this is a very common type of SQL injection, very basic one also. So yeah. So key takeaways is that network firewalls can't analyze HTTPS and HTTP requests coming from designed to go to a web server, and that leaves the web servers vulnerable to many web-based attacks such as cross-site scripting, DDoS attacks, and as what you just seen, SQL injections. So what device can be used to prevent these attacks? Well, the answer is web application firewalls. So web application firewalls can do what network firewalls can. That's what they monitor: HTTP and HTTPS traffic. They look for any suspicious requests that could pose a danger to the web servers, and if it finds any, it will block all those requests while also letting in valid traffic in. And of course, this operates on the application layer of the OSI model. So when you're sending information to a web server, it's going to operate on that web-based layer. So how do WAFs detect for malicious payloads or malicious traffic? So there's 3 ways. The first way is through rule-based detection, in which it uses predefined rules to detect attack patterns in these packet requests. So it's going to look through the content of the packets, and it's going to look for certain queries like /or1 is equal to 1 for SQL injection, where it tries to, it's going to look for if the malicious user is trying to make the SQL query always come out true. It's also going to look for certain comment syntax, such as 2 dashes or */ which is used to comment out stuff in a SQL query. It's also going to try and see, okay, is there going to be cross-site scripting? Certain queries, certain text it's going to look out for is the script or iframe, which can be used to display certain images or run certain scripts onto the user's screen. And then there's also directory traversal, where it's going to look, it's going to see if the content of the packet is trying to navigate to a different non-authorized place within the web server files. It's also going to look for wrong headers or malformed headers, size limits. If there's a giant, if the packet's too big, then it's going to rule it as suspicious. And yeah. So that was rule-based detection, in which they check the content of the packet. Signature-based detection looks at the whole packet. The WAFs have a database of all the known attack patterns that could be seen as a web-based attack. It's going to check these requests and check the URLs. It's going to look for the headers. It's going to look for where the packet's trying to go. And it's going to say, okay, does this match any of the signatures we have in our database? Because these WAFs, they have a whole database of attack patterns. And it's going to block any requests that contain a known signature in that database. And lastly is behavior-based detection. So when you install a WAF into your network, it's going to be constantly looking through the network traffic, and it's going to start to develop, okay, what looks like normal traffic? What is the norm? And when anything falls outside of that norm, it's going to flag it as suspicious or possibly block that suspicious traffic. And suspicious traffic could include if there's an influx of requests being sent at a certain time, at a very irregular time, which could possibly indicate a DDoS attack. It could see if there's a request parameter is bigger than usual, which could be indicative of cross-site scripting, because scripts can be pretty big. And so if there's a packet that has a lot of text, it could flag that as unusual, and other weird traffic patterns. So if they see, again, if the behavior-based detection is looking, it has its own set of what looks normal, and if there's anything that deviates from the norm, it's going to flag it or block it. So let's see the WAF working in action through the same example we had previously with our SQL injection. So let's say a malicious user has the same username, which is the basic SQL injection attack. And again, it's going to go through the same process. It's going to go through the network firewall. The network firewall is going to see it's coming from a valid IP address, going to a valid port, and it's going to say, yep, you're good to go. But before reaching the web server, it's going to reach the web application firewall. Now, next. Now, this firewall is going to investigate the request. It's going to look through the content and see, okay, there's some very weird text in the username section. It has or +1 is equal to 1. It's going to see that as a rule-based detection, meaning it's going to find out that, oh, this looks like a certain SQL injection attack, and it's going to flag that as suspicious. And it's also going to see that it's a suspicious pattern. If you see it's going to look at the whole HTTPS request and find out, this SQL injection is trying to go into is being attempted on a login section of the website, and that's going to be signature-based detection. It's going to flag it. Okay, this is definitely a SQL injection attack, and we're going to block it. So again, the WAF rules this as a potential attack, and it's going to block the request. So what are the benefits of implementing a WAF? Obviously, it protects your web servers from web-based attacks. Even if the web server doesn't have very secure code to validate certain inputs, the WAF will be there as an added layer of protection against those attacks on either it can be logins or search queries and other applications in the web. Then it's also all those web-based attacks and all the traffic is going to be centralized to the WAF because it solely works on the web application, the application layer. And so all of that is going to centralize all those logs into one device. Now that you know why web application firewalls are important and how they are and why they are necessary, here's how you can deploy them. So what are the different ways organizations deploy these firewalls? So one of the ways to deploy it, So first of all, where are WAFs typically placed on a network? They're going to be in between the network firewall and the demilitarized zone, which is where the web application firewall is located. And there's some certain exclusions to that. Sometimes the WAF is going to be installed on the web server. We'll get into that in a few slides. But basically, they're going to be placed in line between the users from the internet and the web server. And for cloud-based WAFs, they're going to be placed on the internet, the network edge where they can see pretty much anything that's going to be web-based. So there's three main types of deployments. There is hardware, software, and cloud. So I'm going to talk about each. So first is hardware-based WAFs. This, as you can see the image, this is what a WAF typically looks like. It's kind of hard finding the image because usually it's software-based, but we'll get into that. So this is going to be a physical device that sits in front of the web servers. The benefits of having a hardware-based WAF is that it's the business, the organization who has it, they have full control, full autonomy over how they want to configure the WAF, what type of what web servers they want to protect, and other certain devices that operate within the DMZ. It's also since it's also hardware, it's also high performance and low latency, which means it works faster and it works really fast. However, some weaknesses, since this is hardware based, it's going to be used metal, plastic. It's going to be more expensive to purchase, and especially if your organization is growing, it's not scalable. So if your organization is growing, you're going to have to buy additional hardware-based WAFs. That's where software-based WAFs come in. Software-based WAFs are installed on the host system. So like I said 2 slides ago, they are generally installed on the web server, and they're very customizable. And one of the best is obviously it's way more affordable than buying a physical WAF to place in your organization, and it's pretty easy to scale up as well. However, there are some weaknesses to having a software-based WAFs. It requires additional maintenance. Again, if you're adding web servers, although it's easy to scale up, you'll have to incorporate those web servers into the web application firewall. And the greatest weakness is that since it's going to be installed on the host system, it's going to use the resources like CPU, RAM, other resources that the web server utilizes to display pages to users. It's going to be taking some of that resources away. So that's one of the caveats to having a software-based WAF. And examples of software-based WAFs include Cloudflare, Microsoft Azure, and Imperva. All these are software-based WAFs that can be implemented into your network. Now, including these are cloud-based WAFs. So as you saw from the last slide, all those previous software-based web application firewalls do also have cloud-based alternatives. And one of the big benefits from having cloud-based is that it's a managed service. So it also utilizes machine learning to detect for malicious patterns. And also it doesn't use, for the most part, the resources of the web server. It's going to be using, again, resources from a data center since it's cloud-based, right? And examples include Amazon Web Services. They do have cloud-based web application firewalls, and Akamai, I believe is how it's pronounced. So now that you know about how to deploy them, now it's time for integration. So uh, sorry, let's go to the next slide. So first of all, it's important to understand what type of logs these web application firewalls produce. So web application firewalls produce many logs. They log what type of traffic is being sent at what time. It documents all the accepted HTTPS requests that they allow to go to the web server, as well as denied requests. And they also log what type of security rules were involved, or what security rules were detected that led to a certain request being denied, and also metadata from a packet, including the IP address it was sent from, the user agent, the time in which the packet was sent, etc. And the importance of these logs is that they can be used for forensic evidence. So in the circumstance that a security event occurs, it's important for analysts to analyze what the full scope of what this security incident is looking like. And of course, and furthermore, this is just one layer of the whole OSI model framework. There's also information from the network layer, from the transport layer. All these layers could help a security analyst understand what's happening, what does the security incident looking like, what are we dealing with. So it's important to have these logs integrate with other systems. So why is it important to integrate these logs produced from web application firewalls to different systems? Well, first of all, again, they only log traffic for the most part, from layer 7, the application layer. And security incidents could involve lower levels. And this can include network firewalls, as I stated in the start of my presentation, where the network firewalls can detect what certain IP addresses are trying to log in, are trying to connect, are trying to access the network. And also intrusion detection systems, where they could find out what type of who's trying to get into the network, and other devices that create logs from lower levels. So combining all these logs and allocating them into one central place allows security analysts to properly understand what a security incident looks like. So if we want to integrate all these logs with other logs from different network devices, you'd want to use a SIEM, or Security Incident and Event Management System. This system basically collects all these logs from all these different security devices and allocates them and puts them into one centralized place. So it allows IT to monitor their entire organization's network. So forwarding logs to a SIEM. So when a WAF is producing logs, you'd want to forward that to a SIEM system, so it could be utilized by people who are meant to analyze them. So like SOC analysts or stuff like that. I'm going to show you a general process as to how you would forward logs from a WAF to a SIEM, but just take note that the exact process differs between what type of web application firewall service you use and what type of SIEM service you use. So depending on what type of, maybe it's Splunk, maybe it's Waza or something like that, if you're using a certain different type of SIEM, the exact process would look different. But here is what a general process would look like. So first of all, the most important part is you want to make sure that the firewall is producing logs of web traffic coming from the internet. Then once you know that's producing logs, you want to choose how you want to forward these logs to the SIEM. So one of the options is syslog, in which they produce logs in a syslog format. It's very text-based. I should have added a photo of it, but yeah, syslog is a very very general process of way to send logs. So how you do it is on your web application firewall, you would provide the seam's syslog collector IP and port. So what does that mean? So a seam would have a certain part of their software that allows them to connect with the WAF and get logs from that device, and that specific collector has an IP and a port. So you would take that IP and port where you can get that syslog collector, and you have to import. You have to take that and let the WAF know, hey, this is where you're going to send logs to if you're doing syslog. And on the seam, you would enable the collector to start intaking syslog logs. The other option is HTTPS API webhook. So basically how this works is that instead of sending it in a syslog format, the WAF is going to send it in a JSON format. It's a type of like code format, I guess. And and it's going to be sent over HTTPS. So instead of being sent through other layers, it's going to be sent web-based or through HTTPS. So what's going to happen is on the seam, there's going to be a log source or a data collector for these web-based logs, and it's going to generate an endpoint URL. So basically, this URL is what you're going to give to the WAF to start sending logs to that link, to that URL, so then the seam can utilize it to aggregate those logs and to have them be centralized with other logs from different other network devices. And the last one is cloud storage. So if you have a very big organization and you have a lot of logs coming through, then you're going to want a cloud-based solution for this. So for large volumes of logs, the WAF is going to send all of this information to a cloud bucket, which is basically a very big container that just stores all of these logs and it labels them and stuff like that. So, and then from that cloud-based container, the seam will be able to access that and utilize it again to aggregate and to monitor your network and your web servers. Then, after you configure your WAF on the proper way of how to send those logs to the seam, your seam is going to need to know how to translate those logs in a way that it could properly parse them and read them. So again, and as you can see, the seam needs to be able to understand the logs being sent from a WAF. So on the seam, you're going to let's say you want to send syslog logs, then your seam is going to need a syslog parser that matches the format of the logs being sent to your WAF. So when the seam starts filtering, allows the SOC analyst to filter through timestamps or users, it'll be able to parse those and put it into certain sections that allow the user to filter through the logs. And then you want to test and verify. So you want to make sure that these logs are actually being sent to the seam and that it's being interpreted correctly by the seam and that it could be used and utilized. So when a security incident occurs, it can be able to be used to get a whole scope of what your network is looking like. And then that's it, you're done. So throughout this presentation, you've learned what web servers are, how they need to be, why and how they could be protected through web application firewalls, how they're used, so how they work, how they can be installed on your network, and how you can integrate that WAF with multiple other security devices that can allow your organization to properly understand, can better be able to map out what their environment looks like in the case of a security incident. So on Friday, this Friday, there's gonna be a workshop where you'll be able to try to attack a vulnerable web application, and then you're going to set up a WAF on that web server, and then you're going to try and test out to see if it blocks these web-based attacks. So that makes you come to Friday, and thank you for listening to my presentation.